Just a minute. I'm trying to open module 12. Please open.
Let's take a moment to review. In this module, we'll cover requirements for IACS service providers, types of providers, product security development lifecycle, and technical security requirements for IACS components. After completing this module, you should be able to identify ISA IEC 62443 Part 2-4 as the guide for requirements for IACS service providers' activities. Identify ISA IEC 62443 Part 4-2 as the guide for technical security requirements for IACS components. Discuss product security development lifecycle requirements. Identify types of service providers, including integration service provider, maintenance service provider, and product suppliers, and describe ISA secure conformance. 62443 Part 2-4 covers requirements for the IACS service provider activities. It was published in 2018. The service providers are required to have technologies and process procedures that are considered secure. Part 2-4, Annex A, has a list of about 130 normative requirements for service providers. Wow! The specific terms and conditions for providing these requirements are beyond the scope of this course. Service providers can be a course all by itself when you add in Parts 4-1 and 4-2. Part 2-4 is one of the standards that you can't view unless you purchase a copy. Check with your organization. They may have a subscription to ISA or IEC that includes Part 2-4. What is a service provider? It's an individual organization that provides a specific support service and associated supplies, generally as an agreement with the asset owner. There are integration and maintenance service providers. The concept also includes the product suppliers. In the 62443 standards, the provider and supplier terms are used in the place of the generic word vendor to provide differentiation. This part of the ISA 62443 series defines requirements for security capabilities to be supported by security programs of integration and maintenance service providers. We can describe integration service providers as having the capability to implement and deploy automation solutions according to the asset owner requirements and needs per the contract. The integration service provider activities generally occur in a design phase, and they end in the handover of the automation solution to the asset owner. The typical integration service provider activities include analysis, development, definition, installation, configuration, patching, backup, and testing. They are gaining approval of the asset owner during the execution of the different activities. Once we have everything set up, whether it was a greenfield, new build, or a brownfield, upgrade, who's going to take care of it? Who's responsible for the care and feeding of the system to include the security controls we've established with our risk assessment? This would be the maintenance service provider. It could be that the integration service provider is also contracted to provide the maintenance services. By now, you probably have the contracts in place. The maintenance service provider performs those activities that maintain and service your solutions according to your asset owner requirements. Maintenance activities are separate from operation activities, but they must work with operations. We generally start all of this after the handover of the solution, which is your control system. Maintenance providers continue until the asset owner no longer requires them or takes it over themselves, or maybe the system is going to be retired or upgraded. Some of the typical provider activities are patching, antivirus updates, equipment upgrades, and maintenance. Other responsibilities can be component and system migration, change management, management of change, the documentation and contingency planning that must be done for recovery operations. If something goes wrong, how do we get it fixed? What equipment is going to be stored on site? Maintenance providers can also help with cybersecurity acceptance testing and factory acceptance testing. Next, we have our product suppliers. They manufacture the hardware and software products. They develop these control systems as a combination of supporting applications, embedded devices, network components, and host devices. These are the four groupings that they're using in the standards. They're normally independent of your control system environment. They hand it over to the asset owner. They may provide maintenance support and everything else, but the product suppliers are on the hook for the products. Maintenance activities may be shared by the asset owner, the integrator, the maintainer, and a product supplier. There's lots of overlap and no clear-cut delineation. Think about the organizations you're in. Who's taking care of all this? How's it set up? Are you using external vendors, contractors, product suppliers, integrators, and/or maintainers to take care of this for you? Parts 4-1 and 4-2 cover a lot of ground and could easily be a separate 2-day or longer course. The intent of this section is to introduce Parts 4-1 and 4-2 by providing a high-level overview. 62443-4-1 is the Secure Product Development Lifecycle. 62443-4-2 covers technical security requirements for IACS components. A copy of these standards are not provided with this course. However, your organization may have an ISA subscription or they can be purchased. The main audience here is product suppliers. Parts 4-1 and 4-2 apply directly to them. So 4-1 is the Product Security Development Lifecycle requirements. The primary goal is to provide a product framework addressing security by design with a defense in-depth approach. Building, maintaining, and retiring, cradle to grave. They want to support meeting the capability security levels. Known security vulnerabilities are eliminated. They make sure they're mitigated. So, in the product security development lifecycle, the secondary goal is to align the processes to meet the needs of the industrial users. The security configs, patch management, policies, and procedures are aligned. Communications about uncovered product security vulnerabilities are addressed. A key concept is the use of threat modeling and the impact analysis and resolution. The key philosophy is a defense in-depth strategy. A defense in-depth strategy is a key philosophy to both a secure product lifecycle and the security development lifecycle. In the center is our defense in-depth strategy. Security management looks at security defects, related issues, and documentation updates. How do we know a product supplier is meeting the practice requirements and benchmarks? Benchmarks have been set for complying with requirements. There's a capability maturity model integration for development, CMMI Dev, used in the standard. It ranges from Level 1 ad hoc processes to Level 5 maturity, demonstrating metrics and continuous improvements. Level 1 typically performs product development in an ad hoc, often undocumented, or not fully documented manner. As a result, consistency across projects and the repeatability of processes may not be possible. Level 5, quantitatively managed, optimized, and used as suitable process metrics and demonstrated continuous improvement. And you have the other levels in between. You have benchmarks. It's possible that an organization is going to discover it's not ready to implement all the requirements to the same level of maturity. Security has a cost-to-benefit ratio for risk management practices. There are 47 practice requirements ranging from the development process, threat modeling, to secure operation guidelines. You can get more information in Part 4-1. Do not confuse these levels with the security levels 0 through 4 discussed earlier. This has to do with the product supplier maturity model. They have their own scaling of Level 1 through Level 5. but it does include all the security requirements. Who's the audience for the technical security requirements of Part 4-2? The audience for these standards would be system integrators and product suppliers. The integrators assist in procuring the control system's components that are going to be installed. They specify the required security capability level of the individual components. Components are chosen to provide the necessary capabilities to achieve the SLT for each zone. So we have health, safety, environmental, financial, and reputational consequences in these systems. The product suppliers understand this. They understand the requirements placed on the control system components, so they can meet those security-capable levels that will provide the documentation of how to properly integrate the component into the system to meet a specific security level target. I mentioned the 4 types of components earlier. Software applications include operator workstations and data historians, embedded devices with PLCs and intelligent electronic devices, IEDs. Host devices may include operator workstations and data historians. The 4th type of components are network devices. These include your switches and VPN terminators. So there's a series of component requirements, CR, and requirement enhancements, RE, specifically for components which is defined in Part 3-3. They're built on the foundational requirements, FR 1 through 7, and the security levels 0 through 4 that are in the 62443s. The Common Component Security Constraints, CCSC, applies to all the components, supports essential functions. It also accounts for compensating countermeasures and least privilege. Then software development processes, they have component requirements, requirement enhancements, and here the component requirements are common to everything. We have the software, the embedded devices, the host devices, and the network devices. Don't get wrapped up in the acronyms. Not necessary to know all that. We're just trying to introduce you to what ISA Secure is doing and how that works with the 62443s. The ISA Security Compliance Institute, ISCI, manages the ISA Secure Conformance Certification Program. That's a separate division of the ISA organization. They don't operate an internal testing lab. They partner with qualified labs to do this testing to independently certify these products and systems to ensure that they're robust and free from attack vectors and known vulnerabilities. None of this testing was done years ago on control system equipment, like IT has had for many years in the government and military doing cyber testing. It doesn't offer assessments of integrator site engineering practices. They don't come out and say, okay, you're at this level and we certify you, but they do certify off-the-shelf systems. This slide includes some certified samples off the ISA Secure site. Honeywell, GE Power, ABB, maybe you work with some of this equipment. The certifications include requirements that are found in Part 3-3 and Part 4-1. You see the levels there in that certified sample. They have Level 2, Level 1. Don't get those confused with the security levels we introduced to you earlier. The security levels 0, 1, 2, 3, 4. They map to each other, but that's a different concept than when we talk about security levels 0, 1, 2, 3, and 4. Here we're talking about conformance certification, and they have their own level numbering system. That's Level 1, 2, 3, and 4. The certifiers perform system robustness testing, the fuzz testing, the network traffic load testing, vulnerability scanning. And if you go to their site, you can see what type of tools they're using for doing this testing.